Hi, Year Nines. Today we're looking at index notation. So our learning goal for today is I will review index notation and be able to convert between expanded form and index form. Now you're actually probably more familiar with index notation than you'd think. This is just talking about numbers like 2 squared or 3 cubed or 4 to the power of 8. This is an index. So this little number up here, that is our index. And this number here is our base. So for instance, 2 squared, which we know is 4, if we want to write that as index form, it's going to be 2 to the power of 2. No retrieval quiz today as we are working from home. So our key ideas. Indices, which is the plural of index, can be used to represent a product of the same factor. So if all of our factors are the same, we can represent it as an index. So in this instance, we've got 2 times 2 times 2 times 2 times 2. That is our expanded form. We could turn it into index form by just writing it as 2 to the power of 5. If we were then to compute that, we would get 32 as our basic numeral. So what is that number if we actually solve for the sum, or in this case, the product? The base is the factor in the product. So in this instance, we have a base of 2, whereas in this instance, we have a base of x. So the base doesn't have to be a number. It could be a pronumeral. It could even be a bracket if you had something like x plus 3 squared. The base would be our x plus 3 there. The index, which is also referred to as the power or the exponent, is the number of times that thing is written. So 2 to the power of 5, we write it 5 times. Something that's important to note is anything to the power of 1 is just itself. What we're saying there is if a squared is a times a, well, a to the power of 1, we're just going to write that a once. And so anything to the power of 1, you're just writing it once, which is going to be itself. We can then use this idea of indices to do what we call prime factorization. So prime factorization involves writing a number as a product of its prime factors. So just a reminder, prime numbers are divisible by 1 and itself. So some of the primes you're probably familiar with are 2, 3, 5, 7, 9 wouldn't be one. 11 would be our next one. So obviously, just from the get-go, we know that all even numbers except for 2 are going to be prime, and then 3 is prime, but 4 is not because it's even. 9 is not because it is divisible by 3. So we're just looking for numbers that are divisible by 1 and itself. If we take our 108, we notice, hey, that's an even number. So we can actually split it into 2 times something. Any even number can be represented as 2 times something else. In this case, 2 times 54. Well, that 54 is then also even, so we can take out another factor of 2, and that leaves us with 27. That 27 isn't prime yet, so we still keep going. It's going to be 3 times 9. And then that 9 also isn't prime, so we split that into 3 times 3. If we take all of these prime numbers that we're left with, 2, 2, 3, 3, and 3, and multiply them together, that is our prime factor form. We also include the indices just to make it a little bit clearer. So 2 squared times 3 cubed is 108 in prime factor form. Let's have a look at some examples. So if I were to take something that is already in index form and write it in expanded form, it's pretty simple. All I'm doing is just writing it the number of times I'm told to. So a cubed is going to be a multiplied by itself 3 times. If it is a product inside our bracket, so for instance, x times y, that's what's going on in here, we write out each individual part of the product 4 times. So you notice that this is also the same as x to the 4, y to the 4. So 3 different ways, 1, 2, 3, that I can write the exact same thing. For part C, we have 2a cubed b squared. So we have to acknowledge that 2 at the start, but then it's just like what we've done before. So 2 times 3 lots of a's and 2 times 2 lots of b's. So we get 2 times a times a times a times b times b. If we have numbers now, it's the same process, but now we can take it a little bit further. So if I've got 5 times 5 times 5, that would be my expanded form for 5 cubed. But something like negative 2, we can take a bit further. So negative 2 times negative 2 times negative 2, 2 more times. Because we have 5 negative numbers here, each of these pairs, so negative 2 and negative 2, and negative 2 and negative 2, are going to make a positive product. So anything that's positive multiplied by another negative is going to give us a negative. So we can rewrite this as a negative 2 times the other 4 2's. Last example for this, expanding with numbers, is 2/5. So if we have a fraction and we take it to the cubed, we do what we would do usually, but for both the numerator and the denominator. So we've got 2 times 2 times 2 in the numerator and 5 times 5 times 5 in the denominator. Okay, if we have them in expanded form and we have to take them back to index form, all we're doing is grouping all the numbers that are exactly the same. So this group of x's can be changed to be 6 times x to the 4. This group of 3/7 can be written as 3/7 squared, and this group of 4/5 can be written as 4/5 cubed. And then for part C, we've got 2 a's and 1 more a, so that's a cubed. We've got 8 times 8, which is 8 squared. And then we've got b times b times b times b, which is b cubed. So answer for that's going to be 8 squared, a cubed, b cubed. You might think, why don't we just turn this into 64? Well, it's because we're asked to write it in index form. So we're going to leave it like that. If it said prime factor form, we'd even take it a little bit further and turn this to be 2 to the power of 3 to the power of 2. Okay, last example. Let's look at this idea of prime factorization with the number 48. So as we discussed earlier, this is an even number. So my first step is always going to be, let's take out that 2. I'm still left with an even number, so I'm going to take out another 2. Oh, look at that. It's still even. Take out another 2. Still even. And look at that. Without doing anything complex, just by looking at each of these being even, I have been able to get down to my prime factor form. So 2 is prime and 3 is prime. So our index form is going to be 2. This is going to be to the power of 4 because I've got 4 2's times 3 to the power of 1.